the Daily Space Weather. I'm your host, Dan, a.k.a. smAsho. We're starting things out looking at the sun in 171 angstroms, as well as colorized magnetogram to see two sunspot groups in the northern hemisphere, sunspot group 2811 and single umbra alpha group sunspot 2812. No other groups on the visible part of the disk. Possibility for coronal mass ejections is at 100%. We'll show you why momentarily. First, some more imagery of the sun. So here's the magnetogram, and you can see the stability of those two sunspots over the past 24 hours there. Not a lot of changes to the fields associated with those two groups. The leading group, sunspot 2811, again, is beta class, increasing the probability for solar flares a little bit. We did see a nearly C-class flare yesterday. And that large B-class flare should show up in this video. I'll let it play through a second time here. This is 304 angstroms. And I believe it was when this filamentary stuff happened right here, just ahead of sunspot 2812. Not super bright, although we will show you additional wavelengths. Here's 171 angstroms. And by the way, today's Daily Space Weather video is a YouTube exclusive. Here's a close-up of just the northern hemisphere in 193 angstroms. Nice view of the north solar polar coronal hole. And let's get to the diagram of the solar system. Here's where stuff is now. There's where things will be in a week. And here's the coronal mass ejection that we're talking about. This is 100% going to eject, although it's not done yet. If you look in this area right here, and this object that we covered yesterday, now looking like a comet, it looks like it's begun to accelerate toward the sun. This object right here. So if you look at this portion right here, you're going to see a building bit of plasma right there. There is a 100% chance that's going to eject at least part of it. And we may make another video later today documenting it. And stereo A is located at Lagrangian 0.5. For you new viewers, the Earth would be out in this direction from the view of stereo A. Here's a star chart. And you can see a bunch of planets there on the ecliptic. It's Saturn and Jupiter and Mercury and Venus practically overlapping the sun here. The 10.7 centimeter radial flux has dropped back down to 79. And here's a chart from solon.info/solar. To put that into perspective, the top line there is the 10.7 centimeter radial flux. That black line there. The red line is the sunspot number. Note how proportional those two solar outputs are. And here's the NOAA forecast. Let me just make sure that's refreshed as we see some geomagnetic storm conditions forecasted for the 28th. So early on the 28th, looks like the arrival of a coronal hole wind stream is expected around then. I won't argue this or refute this forecast at this point. So you can see geomagnetic unrest expected to begin by NOAA late night universal time on the 27th. Volcano rundown. It's an uptick, folks, and Fagradalsfjall may be erupting for a long, long time. Some estimations done on how long the lava flow will take to fill the upper Caldera Valley, making it into a shield volcano. We could be watching the evolution of a volcano from a cinder cone to a shield volcano. Mount Abico, On Paramushir Island, also erupting, 5,000-foot ash plume there. Sakurajima exploding, 8,000-foot ash plume there. Dakono exploding, 7,000-foot ash plume there. And Veniaminoff on the Alaskan Peninsula, explosive, effusive eruption happening there as well. No evidence of more distant ash clouds since the morning of the 24th. Seismicity remains elevated. Pacaya in Guatemala, and by the way, Veniaminoff is located on the Alaskan Peninsula. Pacaya in Guatemala exploding, 10,000-foot ash plume there. Lava bombs were ejected. Don't be in the way of a lava bomb, and don't pole vault the caldera. Mount Fuego in Guatemala, volcanic ash not observed in satellite does not necessarily mean it's not erupting. Sangay exploding in Ecuador as well as Revenador. Although we don't see volcanic ash on the Revenador satellite imagery, Sangay producing a 20,000-foot ash plume. Intermittent emissions at the Peruvian Sabancaya volcano. And Piton de la Fournaise on the Isle of Réunion has, let's see, some ground deformation, likely caused by a source at depths between 1.5 to 2 kilometers beneath the Dolomio crater, where a shallow magma chamber is likely forming. Sulfur dioxide and carbon dioxide emissions continue at elevated levels. By the way, if you're wondering what's going on with Fagradalsfjall right now, here's Fagradalsfjall, and take a moment to take in the pristine beauty as the crater valley starts filling up with lava, folks. And you can see that cinder cone is getting more and more looking like a shield volcano as time goes on. And I can't pronounce the name of the channel, or I'd refer you to have a watch. By the way, I would invite you to our own website, smashomash.com. Smashomash.org will redirect you to this page. You can find some of our smashomash.org Presents the Sun videos, as well as links to our social media and our merch shops. Thanks to everybody who capitalized on the Magic 15 promo code. Sorry, folks, that promo's over. Thanks to everybody who's purchased merch from the Redbubble and Teespring shops. Links to those on the homepage as well. Some brilliantly designed gear. If you haven't checked it out, you can link to it all at smashomash.com. What's up with Fauci? Did you see our video? In any case, let me take the opportunity to say, shut up, Fauci. Fauci, shut up. As he is an admitted fraudster, as he lied to the public both about the efficacy of masks and herd immunity vaccination requirements. We made lyrics and a parody video. If you didn't see it yesterday, check out our playlists. Thanks to our new subscribers, by the way, over at YouTube, youtube.com/smashomash. Again, check out our playlists. We've got the COVID Chronicles. We'll be making another video about the COVID Chronicles then and now, talking about what happened a year ago. Check out our forum as well for a coronavirus forum, smashomash.com/forum. And if you're new here, please don't forget to press like and subscribe. Leave us a comment and share the videos with your friends and foes. Again, COVID Chronicles coming out later today. Let's check the earthquake rundown over the past 24 hours. No major quakes. A deep quake at New Zealand of a 4.1 magnitude. A deep quake at Japan of 4.3 magnitude. A deep quake at Tonga of 4.6 magnitude at over 400 kilometers. A deep quake at Argentina. A deep quake at New Zealand. So quite a few deep quakes there, folks. Whether that has predictive value or not, I'm unconvinced. There's also a 4.4 at Peru at 147 kilometers in the past 24 hours. Again, no major quakes. And we see a Fijian quake here at over 570 kilometers, a 4.5 magnitude, coming in a couple of hours ago. Next, back to solar data here. Here's the GOES X-ray flux. And we saw this nearly C-class flare that happened yesterday. Peak flux occurred around 1510 Universal Time. 10 after 3 p.m., folks. No strikes on the GOES proton flux, and no surprises to our channel, as we would have told you about this before it happened, most likely. And let's get into some magnetic data. Here's the GOES magnetometer over the past 3 days. Nothing to really write home about there, although these sawtooth patterns are the effect of the coronal hole wind stream, folks, as plasma gets heated up, oriented to, and aligned by the magnetic fields. Plasma also has the ability to block the measurement of the fields, and that's another reason why you see these spiky sawtooth patterns during coronal hole wind streams. Let's take a look at the heliospheric current sheet. Here is the polarity of it, and did I just see the North Pole current sheet vanish? Indeed, I did. It looks like the earthly portion of the solar system is going to have a South Pole only current sheet here. And don't be surprised to see that pop back into view. There are some large filaments in between Earth and Sun right now. You can see this bunched up region right here. And that will affect the magnetometer readings going forward. I'll let that play through one more time here for you. You can see the snapping closed of the North Pole current sheet. Keep in mind, folks, there is a North Pole current sheet still there. It's just that this is the measurement from the ecliptic plane, the portion of the solar system where stereo A, stereo B, and planet Earth are located. In other words, if you went to farther north latitudes, you would still find a North Pole current sheet. Here's a line of sight plot, and this will show you the sun's B field in blue. And you can see the sun's B field being yanked up here toward the north at the end. You can see the last frame, the B field returning to this very solar minimum-like state as the sun takes its time in the solar polar field reversal process. Have we mentioned that I've explained the solar polar field reversal mechanisms? Yes. I can't tell you about it in a video yet because I've got to publish a paper on it. And when it's submitted for peer review, we'll make a video at the same moment. Next, looking at detected filaments here and detected sunspot groups, you can see alpha class sunspot 2812, beta class sunspot 2811. And we see some filaments here on the Earth-facing portion of the solar disk. And again, keep an eye on stereo A as we see a large coronal mass ejection propagating as we make the video. KP index currently at 2, having reached geomagnetic unrest for a brief period of time earlier today. In fact, today, March 26th, started out with some geomagnetic unrest. Next, the real-time solar wind data. And we see this additional pulse, another coronal hole wind pulse here, having calmed down over the past 12 hours. Current conditions are 4.44 protons per cubic centimeter for the solar wind density. Solar wind speed now down to 421 kilometers per second. Everything else fairly uneventful. Here's 4 hours of geospace magnetosphere movies. We're going to show you 4 hours of the pressure today. And we can expect to see a diminishing pressure there with the diminishing solar wind speed. Fairly equalized pressure here over the past 4 hours, it looks like. And the units here is nanopascals. Again, that's 4 hours of data. Here are ground magnetic perturbations. We show it daily as well since there is a geomagnetic excursion going on during which the Earth has 2 north poles. The net pole is here, but we've also got a north pole over Siberia and one over northern Canada, which is weaker, and the south pole is someplace down here, south of Australia in the southern Indian Ocean. Anyway, there's 4 hours of data of ground magnetic perturbations. We show it daily since the archival data is not yet publicly accessible. We do regularly stream live to Twitch, and thanks to our Twitch viewers who came over to watch today's Daily Space Weather on YouTube. Again, it is a YouTube exclusive. And again, if you're new, don't forget to press subscribe over here. We're doing things that no other channel and indeed nobody, period, on Earth is doing, or I believe able to do, and we can't really divulge exactly how we do some of the things that we do. It's just the way it works. So we will release the information about how we do what we do. And speaking of doing what we do, let's do a cosmology segment. This one will be only in today's daily space weather video, although check out our playlists as well, youtube.com/smAsho/playlists. There are pushing 200 cosmology segments in there. Let's talk about precession. Precession is the axial wobble that happens with any spinning object. So when you spin a top, you notice that it wobbles. If you spin a coin, you notice that it wobbles. That is the precessional wobble of all rotating objects. Earth's precessional cycle points its celestial pole at one end, Polaris, and at the other end of the precessional cycle, at Deneb, otherwise known as Alpha Cygni, or Cygnus X3, the most intrinsically bright object in the galaxy, the most intrinsically bright object visible in the galaxy from our solar system. More about precession coming. And I want to talk briefly about M87's jet. So you may have seen this article. We covered it yesterday briefly. I wanted to revisit it. It's this article from SciTech Daily about Event Horizon Telescope images magnetic fields at the edge of M87's massive radio source at the core of the galaxy. And this is the jet, the relativistic jet coming out. And I would note that we see portions of the jet where the magnetic fields are aligned perpendicular to the jet itself. You can see the jet is in this direction, and you can see portions of it are parallel and portions of it are perpendicular. I believe what is going on here is stuff that actually is electric, and while everything is not electric, certainly, which is why we have the term electric in the first place, aspects of these collimated jets indeed are. What does precession have to do with it? Well, precession has a lot to do with it. It turns out that when the output of the jets of these galactic cores are aligned with this field, we see greater output. And when it's not aligned with the field, we see lesser output. And precession is one of the examples of what could be causing that. Galactic cores seem to rotate. Precession seems like a plausible explanation. If you haven't seen the article, you can check it out on SciTech Daily. It'll be all over the Science Wire. You can probably find it on phys.org in the astronomy and space section as well. And let's continue on to pick a quote random and quote object using our quantum random number generator. Today's is 561, which will coincide with some object over at the Neil Gehrels Swift Bat X-ray Observatory. And 561 is IGR J16318-4848, a high-mass X-ray binary / neutron star. And there you can see the historic variable X-ray outputs, the transient bursts from that object. And this one does indeed show times of quiescence as well as times of heightened transient states. That's showing you, wow, that one goes all the way back to 2005. So this is probably a very well-studied object. IGR J16318-4848, the high-mass X-ray binary / neutron star. There's the past 30 days of its X-ray transient outputs. Let's take a look at it on Sinbad. Probably going to look like a single point of light. Let's check Aladdin Light. We'll look at some additional wavelengths. I have a feeling it will look pretty detailed on the Chandra. So here it is on the 2MASS, which is infrared light. So a great view of that. It looks like it's in a pretty busy part of space there, folks. Probably close to the Milky Way's galactic disk. And we'll zoom out, and you can see how close to the galactic disk it indeed is. There's the close-up in infrared frequency on the 2MASS. Here's pan-stars. I'll bet it shows up in pan-stars, but it doesn't. So fortunately, I'm not a betting person. I'm not a gambler, folks. And here it is on Chandra, showing us a heap and helping and nothing. And surprisingly not showing up in most wavelengths. And there it is, showing nothing in optical. How about hydrogen alpha? Not really. And we'll just show you the 2 mass once again. There is that object, the high mass X-ray binary, IGR J16318-4848. And we'll close out today's cosmology segment by doing a cosmic ray update. So here are some cosmic ray monitors. It's the Apatity neutron monitor. And you can see an upward trend here at Apatity over the past 30 days as a result of this spike right here. Is it fraud? I don't think so. Barentsburg does not really agree. Barentsburg, a tiny uptrend over the past 30 days, but mostly flat. Let's take a look at Athens, Greece, going much farther south. So here's the 30 days chart. It's the 30-day chart of the Athens Cosmic Ray Station, the neutron monitor. And it is indeed flat over the past 30 days. Even farther south to Mexico City, almost entirely flat there over the past 30 days as well. A tiny uptick. By the way, you can access the archival data at the Mexico City Cosmic Ray Observatory. And lastly, we'll look at Oulu, Finland, and 2 Antarctican monitors. And the Oulu monitor actually does agree with Apatity largely. Small uptick over the past 30 days at Oulu. Here's DOMB Antarctica. Looking pretty cyclical, actually. And indeed flat over the past 30 days. DOMC Antarctica, similarly cyclical. Really, that is a tiny uptick at both DOMB and DOMC. And that's today's cosmology segment. Let's move on, as there's plenty more data to cover. So let's talk electrons. The Earth is surrounded by Van Allen belts, and one of the components of those Van Allen belts is electrons. So we measure them. And these are the greater than 2 mega electron volt electrons. You're looking at density here, electron density over the past year. You can find that chart at solon.info as well. Here's the 3-day chart. Briefly made it into warning levels yesterday. And we may be headed back there right now as we make the video. So here is the electron forecast, which is the green box. And once again, NOAA expecting a downtick here in electron flux. I would expect flat or upward of where we currently are, as I think there are some electrons out there that haven't made it to Earth yet. And here's a diagram of the Van Allen belts. The next slide we show you is going to show the air column to about 12,500 miles, where a GPS satellite will be located, a geosynchronous satellite, and hence we'll be showing you essentially a visualization of the inner Van Allen belt. It's the total electron content forecast. This will also elicit where GPS errors are most likely to be occurring around the equator at noontime. Electrons are pretty organized here. We don't see any major anomalies. If you need to rewatch it, feel free to rewind the video. And if you need to look greater at this diagram, feel free to pause it. Next, we're going to show the ionosphere, which is the F-layer around 300 kilometers. So here's the ionosphere over the past day. And while this will not forecast earthquakes for you, it may show you major trends in ionospheric anomalies. Keep in mind, folks, there are 2 weak spots in the magnetosphere right now. The South African anomaly, as I'll call it, and the South Atlantic anomaly, which is someplace out here. South Atlantic, South African. And we show the ionosphere data daily as well. It is actually looking a little anomalous here, a little wobbly, really, with some surprising charge-ups late in the day. So here's a pretty heavily charged up Indian Ocean here. You can see these little blobs of 14 megahertz vibrational frequency there over the central and northern Indian Ocean. Next, some meteorological data. Here are the jet streams of the eastern world. And check out the extreme meridional jet stream flow here. We see some north to south jet stream flow and some 180-degree bends here in the South Pacific around New Zealand. Here are the jets of the western world. And shout out to Brett, one of our Alaskan viewers. And most of the jet streams are going the right direction now, as opposed to east to west, which would be a backward jet stream. Next, we're looking at snow depth. And we're going to actually advance the Euro forecast here. We're going to go through the weekend. As snow continues to fall into spring, there's where the there's where the Euro forecast expects things to be on Monday at 7 a.m. Eastern Time. Check out all the snow in the western U.S. Places like southern New Mexico expected to see snow. As it continues to snow into spring, apparently it's so hot on the globe that it's cold. Here's lightningmaps.org. It's our real-time lightning map. We show it on the regs. It's what I use when I hear thunder. And hey, Atlanta, you've got lightning to your south. If you've got a clear view, go out and look. Take some time-lapse photography. You may see sprites, as this is a highly active region. And if you're camping in the Chattahoochee National Forest, there's thunder rolling in. Those are the actual thunder expected propagation lines, and they may even tell you something about the air pressure if you understand the physics of thunder propagating through the atmosphere. Next, looking at the U.S. Doppler radar map, and the source of those storms is this long band. There must be a pressure gradient there. There must be some dry, massive air or some very cold air in play. Here's the cloud layer. And you can see likely north of that is where that dry, massive air is going to be located. And indeed, you can see it right here. This large blob of dry, massive air is really what is in control of these systems. Everybody looks at the moisture, folks, and the water vapor is important. The high pressure systems are important as well. And understanding the relationship between the high pressure and low pressure systems means the difference between understanding meteorology and not. And we've got some bonus features here. The first one's going to be the latest data from Udaipur. Oh, wait, this one's El Teide is actually more recent. So here is the National Sunspot Observatory El Teide, Spain imagery of the sun. And you can see some filaments. Again, we'll be probably making another video today about the coronal mass ejection that's occurring as we make the video. Thanks to the true stars of the production, our assistant and associate producers at patreon.com/smashamash. Thanks to our patrons. Thanks to our newest patron. You'll appear on the credit crawl early next month. And by the way, next month we'll also be doing a fundraising contest, a slam poetry contest to give away a free month of Patreon at our lowest tier, which is $3 per month. If you'd like to be a Patreon, patreon.com/smashomash. And here comes some more bonus features. So here's the colorized magnetogram of two sunspot groups, sunspot 2811 and sunspot 2812. 2811 looks like it's actually degraded here. And you see the trailing umbrae look like they're shrinking. Let me refresh this one. So we still do see a South Pole umbra there. The main umbra is this North Pole umbra. And you can see they've shrunk a little bit. Just want to make sure that we have the latest. There we go. So sunspot 2811 may become an alpha class sunspot today. Sunspot 2812 is degrading as well. We also saw a dip in the radio flux. Here is the view of the northern hemisphere. Great view here in 171 angstroms. And here's a full disk view to close things out at 193 angstroms, another ionized state of iron emission spectra. Some coronal holes there around the southern hemisphere and the equator. Those are the source of the incoming coronal hole wind stream, expected to cause some geomagnetic unrest and possibly a minor storm. We'll cover it. Thanks again for tuning in, folks. Remember to stare at the sun, attempt to understand the physics. And when you're staring at the sun, don't drink, but if you do drink, don't drive. Welcome to the Neo-Renaissance, and may that solar wind be at your back.